Now we are going to discuss PN junction diode operation. In this, we are going to discuss biasing, types of biasing, and how the PN junction diode works. Now we are going to see biasing. Biasing means inclination. Here, we are going to activate the PN junction diode with external energy, that is battery source. The biasing is of two types: forward bias and reverse bias. Forward bias means when a positive terminal of the battery is connected to the positive electrode, that is anode, and negative terminal of the battery is connected to the cathode, that is negative terminal of the device, then that connection is called forward biasing connection. Reverse bias means positive terminal of the battery is connected to the cathode and negative terminal is connected to the anode of the device. Then it is called reverse bias. Now we are going to see forward bias. We all know that positive terminal of the battery is connected to the anode and negative terminal is connected to the cathode of the device, as shown in figure. From the figure, P-type semiconductor, that is P part, is connected to the positive terminal and the N-type semiconductor terminal is connected to the negative of the battery. This connection is called forward bias connection. Once the connection is made, positive charges are entering into the P-type semiconductor. The holes are the majority carriers in the P-type semiconductor. Both are positive charged particles. They repel each other. That is, holes are moving towards the junction. Similarly, in N-type, electrons are the majority carriers. The negative charges from the battery and the electrons both are repelled and move towards the junction. The majority carriers from P-type material, that is holes, are attracted by the negative terminal of the battery. Similarly, electrons from the N-type material are attracted by the positive terminal of the battery. Once the particles are attracted by the terminals, the depletion region width is reduced. The width of the depletion region reduces means the resistance of the diode decreases. Once the resistance decreases, the current flow increases. For silicon diode, up to 0.7 volt, there won't be no charge movement in the junction. Once the external voltage is nearing and above 0.7 volt, the carriers are crossing the junction, then the current flow takes place. The current flow is 0 from 0 volt to 0.7 volt, and beyond it increases exponentially. The diode will act as a closed switch or on state. In forward bias condition, the resistance of the diode is very less or minimum. The current flow takes place. The diode is act as a closed switch and the diode is called on state. Figure shows the forward bias condition of the diode, a resistor or a diode. ID is a diode current, maximum current. The positive is connected to the anode and negative is connected to cathode through a resistance. So N-type, P-type semiconductors, the positive immovable ions near the junction in the N side, negative immovable ions near the junction in P side. Battery induced the electric current, electric field. Built in the electric field, 3 is the conventional current and 4 is the electron current. Now we are going to see reverse bias. Reverse bias means the positive terminal of the battery is connected to the cathode and negative terminal is connected to the anode of the device. Once the connection is made, positive charges are attracting the electrons from the N-type and the negative charges are attracting the holes from P-type. The depletion region width increases, the resistance of the device increases, hence the current flow is minimum. The diode is in off state or open switch. Figure shows the reverse biased connection. Negative terminal is connected to P layer, positive terminal is connected to N layer. 1 represents the battery induced electric field, 2 represents the built-in electric field. That current I is 0, that is there is no current flow in the reverse bias condition. The reason is the depletion region increases, the width of the depletion region increases. The width increases means the resistance increases and there is no charge movement across the junction. Hence the current is 0. In the reverse bias condition, the diode is open switch. So we have seen biasing, types of biasing, forward bias and reverse bias in detailed manner. Thank you.